some of the vertical lines in the picture that gets wrongly classified as a 1. So again, folks, it works very, very well, but it's not always perfect. Let's look at something else. Let's look at recognizing celebrities and landmarks. Well, since I am maybe biased towards a certain picture, I think you can already guess which picture I'm going to choose to see if the algorithm correctly recognizes a celebrity. And here it is. The algorithm runs, it sees the picture, and it correctly identifies Satya Nadella, 100% confidence, as being the celebrity in the picture. It's really a great way to just play around with these kinds of algorithms. And you can find them at aidemos.microsoft.com/computer vision. Okay, and with that, let's go back. And now let's take a look at computer vision in Azure, the second part of this module. And we'll start with cognitive services. Because Azure provides you a set of cognitive services that encapsulate common AI workloads, such as computer vision. And you could build your own computer vision model using machine learning, but to be honest, it's a complex area, and it will take you a long time. And I'm not even talking about training time, but getting up to speed with current technologies. It's a lot of work. And using off-the-shelf services can help you develop a solution more quickly and with a lot less specialist expertise that you would need. Now, to use cognitive services, you must provision a resource in your Azure subscription. So you need an Azure subscription, and you need to provision a resource. It can be a standalone service-specific resource, for instance, computer vision, or you can use the general cognitive services resource that encapsulates all the multiple services. Using a standalone service-specific resource enables you to manage the costs and access independently of the other services, while a general cognitive services resource enables you to combine all of your AI services in a single Azure resource. And that was really for centralized management. And regardless of the type of resource you use, at the end, the client applications will consume the services it provides by connecting to a REST endpoint. And of course, you need a resource-specific key for authentication. When we're looking at image analysis, the computer vision cognitive service provides a pre-trained computer vision model that you can use to analyze images. And the model can detect and locate over 10,000 classes of common objects, like you see in the picture here, a person, but an apple, a couch, a dog, a mountain, or jeans, as you can also see in the picture. And it can generate automatic captions for the image and a set of relevant tags that relate to its contents. And these tags, they're very useful because if you need to index images and search for them using relevant keywords, you can use those tags. And we'll look at some fruit later, and then you will see the use of tagging. But we'll get there during the demo. The algorithm can also detect and analyze human faces, including gender identification, and can estimate ages. It can moderate content by identifying images that contain adult, racy, or gore content. And last but not least, there is OCR, so it can detect and extract text in an image. Now, this is a pre-trained computer vision model, but you can also enhance a pre-trained model. So you can train your own model, and you do this by using the custom vision service. You could then use it for image classification or object detection. And the service provides a web-based portal. It's really easy to use. You can upload your own images, you can label the image then, or the objects inside them, and then train and deploy a model. And then, of course, you can again consume the model using the endpoint and key for the resource. But I'll show you this in the demo shortly. We also have analyzing faces using the face service. And while the computer vision service provides some basic face detection, the face service offers additional capabilities. And that includes the analysis of facial attributes and the ability to compare faces for similarity, or even train a facial recognition model to verify the identities of individuals. Really interesting. Reading text we have. We already discussed it a little bit. But of course you can use it